Uno? No, that's a card game, dude. Good afternoon. Welcome back. Last time we were together. Last time we were together. Hi. Hi. Hello. Hello. Testing. 1, 2, 3. Last time we were together, we did surface area, didn't we?
Yes.
We did pyramids and cones. And then before that, I'm flipping through notes here. Before that, we did surface area of prisms and cones. So that was 12-2. Today, 12-4.
Whoa.
Dum, dum, dum. And that's because the other surface area was 12-3. So 12-4 is going to be dealing with volume. So if surface area was how much it took up on the outside of it, like how much paper you would need to cover it, what do you think volume is?
How much space it takes?
Yeah, how much space it takes up. How much stuff can you shove into these things, right? That's the volume. The measure of the amount of space that a three-dimensional figure encloses. Volume is measured in units like cubic feet, cubic yards, cubic meters. It's basically a giant game of Minecraft. It's a bunch of little cubes, and they figure out how many little cubes they can shove in there. Okay? Some cubes might have like a corner chopped off because there's like a face. When we get to the round shapes, we're gonna like start shaving pieces off, but that's okay. We're still talking cubic stuff. Here's your formula. Capital B, lowercase h. What do you think capital B stands for?
Base.
Base. Can you give me more information than just base?
Base area.
Base area. Yes, indeed.
Can I borrow a pen marker?
Sure. Ooh. I want this. And then what did the H stand for?
Hi.
The height of your prism. Beautiful. All right. Let's find the volume of this prism. What shape is the base face of this prism?
Rectangle.
Because that's what it looks like it's sitting on, yes? But remember, the lateral faces have to be parallelograms or rectangles or squares. Are there any non-rectangle shapes? Yes, then that has to be the base. So the base face is actually this triangle right there. So I need the area of this thing because what we've been asked to find is to find the volume of this prism, and the formula for the volume is the area of the base times the height of the prism. So what was the formula for area of a triangle? 1/2 base times height. Now that lowercase b is the base edge of the triangle, and that lowercase h is the height of that triangle. So look at just the triangle, just the yellow colored in piece. What is the measurement of the base of that yellow colored in triangle? 3. What is the height? 1.5. All right, someone who's got a calculator out in front of them. While I pause a moment to take a sip of my drink. I need the area of the base face, please. 2.25. All right. So now I have the base area. I'm going to plug that in there. And now I need the height of the prism. That's the height of the base face. Remember that the height is always going to be perpendicular to the base face. If we said the triangle is the base face, you have to imagine that this thing like fell over. Yeah, this is the height. So basically this was like my cup of pencils that I had up here the other day. Remember there was a triangle thing? And it fell over on its side. My pens went everywhere. That's what happened here. All right, so height is 4. All right, someone with a calculator. 9 centimeters cubed. Easy peasy. I would love to look at number 4. That's it, man. The only way to make this more complicated is to make the shapes look different. That's it. But it's the same thing. Let's look at number 4 together. Are there any non-parallelogram looking sides? Or are they all some sort of four-sided parallelogram? They're all some four-sided parallelogram. That means we get to choose where the base is and we don't have to worry that we're going to be wrong. So which side do you want to be the base face? The one it's sitting on or one of the others? The one it's sitting on. All right, I'm down with that. So here's our base face. We've been asked to find volume. Remember that volume is the area of the base face times the height of my prism. What was the shape of that base face?
Square.
Square, rectangle, parallelogram, one of those. What is the formula for area of a parallelogram? Huh? I thought I heard someone say it.
T.
No, it doesn't have a T in it. It does have a B. Yeah, base times height. Just had to give you the little nudge. Good, well, because I see you guys working without the formula chart, and that's fine, because you know that you'll have that available to you, and you'll remember it then. What's the base edge of the shaded in base face? 10. And the height?
12.
Okay, I heard 12. But remember, you're looking at just this figure down here.
Oh.
15. Good.
Alright.
Multiply them, you get? All right. Gonna substitute that in up here. And the height of the prism. Remember that we said that the height was always 90 degrees to the base face. So here is the plane that the base face is sitting on. And so 90 degrees from that straight up, that's that 12. That's the height, that's how tall it is. Okay, 12. What did you say it was? 1800. You are fast with the calculator, my bro. I don't know what I was going to say there. What would be my units?
Feet.
Feet what?
Square.
Squared is for area. We're going to add one more to that number for volume cubed. Okay? Because with area, you've got to imagine that we have like little squares of wallpaper that we're sticking to the face of everything, and we're trying to cover it all. And with volume, we're trying to get little Lego blocks, and we're trying to shove them in there. Okay, so they're little cubes. Okay? Easy peasy? Good, let's look at cylinders. Easy peasy lemon squeezy. Like some lemonade. The volume of a cylinder is whatever you get when you multiply the product of the height and the area of its base. It's exactly like the volume of a prism. This principle, though, thinking about taking the height of my cylinder and multiplying it by the area of that circle base, is kind of the same idea as if I had taken a cylinder. I happen to have one here. So imagine this cylinder, and then imagine slicing it into tiny little discs, okay? And we're just going to keep slicing. We're going to stack it up until I have discs that are as tall as this thing is. Each disc is going to be the same size, right? Because it's a cylinder all the way up. And if I were to add those areas all together, I would get that volume, okay? So that's basically what is happening with this multiplication, is it's thinking about these slices coming off, like tomato slices. Yeah? Okay. This principle states, this idea of these slices states that if I have two solids that are the same height and have the same slice, cross-sectional area, the same slice area, then they're going to have the same volume. Here's your formula for volume of a cylinder. Looks different from the volume that I gave you before, didn't I? Doesn't it? Looks different? Yeah. But remember, I started off this little section by talking about the fact that the volume was whatever you would get when you multiplied the area of the base by the height. What did you just say right now? Yeah, this pi r squared, what is this representing? Area of a circle. And what was the shape of the base face of a cylinder? It's the same formula. It's just rewritten so that you can see that we're talking about a cylinder. Okay, cool. Let's go practice. Ready? Let's do it. I got 4 problems for you. Which one do you want to see? Six and 8? We'll do 2 back to back? 6 and 8? 7? Okay. So 5 and 7?
Yes.
All right. Look at the difference between these 2 shapes.
One's flat and big.
One's flat. It's called the right cylinder.
The other one's skinny.
Oblique cylinder.
One is kind of leaned over, and the proper word for that kind of leaned over is oblique. Which means now you can impress your friends, and when they show you a picture of the Leaning Tower of Pisa, right? Have you seen it? It's this tower that's leaning. You can go, oh look, it's an oblique cylinder, and they're gonna look at you like, nerd. You're like, that's okay. Nerds are cool. All right, let's do volume for these, yeah? Formula for volume of a cylinder is? Pi r squared times height. Beautiful. What is the radius?
2.
2. What is the height? Good. If I were asking you for the exact volume, just multiply the numbers together and leave the symbol pi. Okay, so that would be the exact volume. And if I'm asking you, just give me the volume and I don't say exact, then let's go ahead and round it to something. Directions say nearest tenth, so it is 12.6? Oh, 56, so 12.6, okay, so feet cubed.
Is that 4?
It is a 4 in the front, yeah, 4 pi. If I were asking for the exact volume. So somehow I would have to fit 4 cubes in there and then 4 apple pies. Get it? Because 4 pi. That was a bad joke. All right, let's do number 7. We want the volume of this oblique cylinder. What is the formula for volume of an oblique cylinder? Yep, pi r squared height. It's the exact same formula. Nicely done. What is the radius of this oblique cylinder? 1.5. And the height of the oblique cylinder? We're just going to go straight to the más o menos answer. 84.8, and this is also cubic feet. If you go to a hardware store to buy things, and you're going to buy a volume of stuff, you might see it written like this. CUFT. CU for cubic, FT for feet. Maybe. Easy enough? All right. Do you right?
I wish I was a cup. Me too.
All right. Do you want to pause here, or do you just want to keep going? We only have volume of pyramids and cones left, and it's really just as easy as this. And just keep going? All right. I like it. Here we go. This figure shows you a pyramid inside of a prism. Okay? And so what you have to imagine on the volume of a prism is that we took this block of something and we cut it so that way we would have a pyramid come out of the cut. And so it shows us that a pyramid has a smaller volume than a prism of the same height with the same base dimension. Okay? So a pyramid and a prism that have the same base and the same height is what we're looking at. It's very clear that the volume of the pyramid is going to be less than the volume of the prism because the pyramid sits inside of it. More specifically, that volume is 1/3 the volume of the prism. And this leads us to our formula for the volume of a pyramid. So you're going to find the volume as if it were a prism, and then you're going to divide by 3. Right? I could make this section so more complicated. I can't make it any more complicated than this. This is it. This is as hard as it gets. Okay, which one of these 4 things do you want to see? I already... Yeah, I had a feeling you were going to go with 12 because, oh my God, it's a regular hexagon. And I didn't give you an apothegm, which means we have to find it. That's some trigonometry. All right, so let's do that first. Come over here. I'm going to draw out my regular hexagon. I know that one of the sides is 6. I know that from the center to a side at a 90-degree angle, cutting it in half is the apothegm. So I'm going to make it a dark black, the apothegm. That's the one I want. Put that bold a little bit. I'm going to draw in a radius. I'm going to find the measure of this angle right here. To find the measure of this angle here at the center, I'm going to take 360 and I'm going to divide it by twice the number of sides. How many sides did I have? I have 6 sides, so twice 6 is 12. So I'm doing 360 divided by 12. 360 divided by 12 is? 30. So this angle measures 30. Now I've got to discover which trig function I'm going to use. Some old hippie. Whoop, whoop, whoop. Looking at the triangle, do I have any information on this, the hypotenuse? No, so all of those trig functions which require hypotenuse, I have to throw away. Which means the only one left is tangent. All right, so the tangent of 30 equals opposite over adjacent. The 3 came from dividing 6 by 2. Because the side length got cut in half to make my right triangle. All right, when I have this set up, I got trig thing equals fraction, and I'm looking for the bottom of the fraction. All I got to do is flip the bottom of the fraction and the tangent. Boom. So the hypotenuse, the apothegm is whatever I get when I take 30 divided by the I take 3 and divide it by the tangent of 30. Make sure you're in degree mode in your calculators. Hit enter. Give me a number round to, I don't know, like 4 places. Give me 4 decimals. You remember where to find the tangent? Yeah, okay. What was it? I can't hear. Okay, you got a negative, which is weird because this is a measurement of length.
So 3 divided by 10 to 30, I got 5.19.
6-1.
That sounds more reasonable. 5.1961. Yours was negative, I think, because you might be in radian mode. Check the top by the battery. Yeah, okay. So then hit dock from the document there and hit the dock button. Then go to settings, document settings, and then change the angle from radian to degree. Yeah, and then you should be able to just hit enter again. You may have to tell it to make it default. Hit enter again once you're back in your documents, and it should spit out that number. And then click OK. Pausing while he sorts out the mode of his calculator. Allowing others to catch up and think what they want to do next. Yeah? Cool. All right, we got the apothegm because trying to find the volume of this pyramid, we know that we need to get the area of the base face. And since the base is a regular hexagon, its area is the area of a regular polygon. And we needed A, the apothem, in order to do that. I did not give myself enough room. Now I just need the perimeter. $36, she said? 6 times 6? Good. Beautiful. All right, so I'm going to need a number from someone here, please.
33.52.
All right. I'm totally okay with only having 2 decimal points now. That's okay. Good rounding, it's fine. That's okay. You could have taken it all the way to the 4 and kept that. It means that at the end your answer becomes more exact to the true value. But at the very end we're going to round to the nearest tenth, so, because that's what the directions say. So hanging on to more decimals as you're working than what your final answer is asking will make sure that your answer is more exact. All right, what's the height of this pyramid? 18, because the height of a pyramid goes from the very tippy top all the way straight down at a 90-degree angle to the base. All right. Calculator buddies.
61.12.
Round to the nearest tenth, so
Oh.
what's my units? Feet cubed. Yeah, cubic feet or feet cubed. They could go either way. You could say it whichever way you want. That's it. That's really as hard as I could make the pyramids. Flip the page, let's do a cone. And then we call it a Dave Dunn-Priester. Right. For a cone, the volume is 1/3 the height times the area of the base. Remember that the base of the cone is a circle, and so the area of that base is pi r squared. This means that your volume formula is 1/3 pi r squared times the height.
This is a 6 circle.
Yes. Oh goodness, I realize that it's like,
Card.
I can't see, Yes?
Yes, it's much better.
Thank you. All right, which of the cones would you like to see us get the volume of? Number 16 was the request. Boom, 16. Okay, is it a right cone or is it an oblique cone?
Right.
It's oblique because the
Oh, I see.
height, yeah, it doesn't hit right in the center of the circle. It's slightly off to the center. Okay? All right. So we want volume. Volume of a cone is 1/3 area of the base times height of the cone. All right, let's find area of the circle. Oops, wrong color. Area of the circle is, what's the radius of the circle? Good. So I'm just going to go ahead and stick this in here, and we'll calculate the volume all together in one step. Okay. So 10. Okay. Now we need the height, which is this. Yeah, we could use Pythagorean theorem because I have a right triangle right here. We could use trigonometry because we have two sides. One side is the other side I know, and I have an angle, so I could use trig. Or since that angle is 45, we can use a 45, 45, 90. Which one do you want to see? The shortest one? In my opinion, the shortest one that requires the least amount of work is going to be the 45, 45, 90. And that's because on a 45, 45, 90 right triangle, when given the hypotenuse, in order to get to the measure of the side leg, all I have to do is divide by 2, multiply by square root 2. 18 divided by 2 is, and then I'm going to stick a square root 2 next to it. That's it, that's the height. So if you want my opinion on the least amount of work, that's it. Yeah, well, we have to stick all that in the calculator. But this is the brainless part. This is mash the buttons like if it were a video game. You know? Use my tactic in Street Fighter, man. Just roll your face on the buttons and hope for the best. Look, I beat my brother that way. What was it? 1,332? 0.86. They want it rounded to the nearest tenth, which is this one. Which means my volume is 1332.9. What's my unit? Yards what? Cubed. So, cubic yards or cubic yards. Either way, I will accept. Whatever you like best. That's it, that's all I had. Like, totally. Thank you, guys. Oh, don't change it. Oh my God, you know what I just realized?
Yeah.
I'm looking at my preview over here of the video recording I just made. My title was totally wrong this whole time I was showing the Algebra 2. I just changed it to the Geometry one that has all. RIP. Watch to the end of the video so that you can get the right title.
You're missing a yellow.
I'm not missing a yellow. I have the yellow here. Relax. Hey, I figured out how to do end cards. So do y'all want to help me with an outro?
What is that?
That's the thing at the very end.
Oh, the
where-
outro that you
the
did.
outro, yeah. So what do I say for your outro? Thanks for watching. What else? Click like if this helped you figure out volume at all. Maybe subscribe so you can figure out the next time I'm doing something in class. See you next time. Was it? What's your who's your favorite YouTuber? Since we're here, just kind of chatting. Which you don't watch? You no? You had said Game Theory, yeah? What's his?
Oh,
Yeah. Yeah. So what's how does he sign off? It's just a theory.
Oh yeah, it's just a theory that. Game theory.
It was like the least enthusiastic ever. Okay, I'm just gonna cut the video here. Bye guys.